with fourth graders learning about heat transfer, convection, conduction, and radiation. And it looks like you guys all have burners on your tables that are underneath pop cans. Look at that. So, Jada, what part of heat transfer is the flame there?
Radiation.
Radiation, that's right. And if I came over here and Hansel, I asked you, what part of heat transfer goes from the can to the water inside of the can?
Conduction.
That's conduction because the can is solid, isn't it? And if I came over here and Fred, I asked you, if you see steam, do you see steam coming out of the top of the can?
Yeah.
What kind of heat transfer is that, the steam?
Convection.
That's convection, right. Now we want to see why, when we flip the can over into a tray of water, why does the can crumple? That's our question for today. And if you want to do this at home, it's really important to use a glove because we know that the can is really hot if it's been boiling for a while. So we're going to go table by table and we're going to flip the can into a small tray of water. And Chase, Mahalit, we're going to see what happens. You ready?
Yeah.
Okay, now we've been boiling this for a while, haven't we?
Mm-hmm.
Okay, so I've got my gloves. Here I go. Does it look like it's moving there, Chase?
Yes.
Now, Chase, did I use my hands to crumple it?
Nope. Nope.
No, I don't think so. Okay, so let's come over here and let's look at table 3. Table 3, you ready? Let's see what happens to our can. Here we go. Looks like it's moving there, doesn't it? Okay, let's come over here. And are you ready to flip it? Okay, here we go, Vanessa.
3, 2, 1, go.
Let's see what happens. It's making all kinds of noises. Pretty weird. Okay. Let's look over here with table 7. Ready, Fred, Mason? Amaya, you ready?
Yeah.
Okay, we're gonna flip it over really fast. Here we go. Oh! What do you think crushed that can? Why did it do that? Why do you think it did that, Amaya?
Because the air pressure outside is larger than the air pressure inside, so it pushed against the can and crushed it.
Fantastic. So it's still, look at that, it's still moving. So the air in the classroom is greater than the air inside the can. So the longer we steamed it, the less air was in the can, right, Fred?
Yeah.
So let's come over here. I see table 2. Now table 2, yours has been steaming the longest, hasn't it?
Yep.
Okay, so does it have more gas inside the can or less? Probably less if you've been steaming it for a while.
There's not much.
So let's find out what happens when we flip this really fast. Let's find out what happens. Oh! Is it still moving?
Yep.
Oh!
That's scary.
So Hansel, why do you think the can crumpled like that? Why did it do that?
Because it doesn't have enough gas inside, so the gas outside is more stronger than the gas inside. So it's like pushing it in because it doesn't have enough gas inside.
Fantastic. So the longer we steamed it, the more gas came out of the can. And then the gas pressure in the classroom, the atmospheric pressure in the classroom was greater than the pressure in the can, and that's what caused it to crumple. Fourth graders learning about air pressure and heat transfer. Fantastic.